let's get started. It's 9:30, we're pretty close to it. My name is Dave Bodnar, and I did this in checking. This is my 10th seminar at one of these shows, for large-scale shows. So that's, I don't know if I should get a pin or an award or something about that, or have my head examined, one or the other. I'm going to change from my normal presentation. Normally, I do a 2-hour presentation on electronics and programming pickaxe chips and gizmos and things like that. We're going to do some of that, but that'll be at the end. I have no idea how long the 3D printer end of this is going to take, so I kind of said, well, let's just take as much time as it takes, and then we'll do what we can squeeze in with the gizmos and gadgets at the end. I purchased my first 3D printer, which is sitting on the end of the table over there, back in May. I figured it was time that I learned a little bit about this technology, and believe me, I don't regret it a bit. I bought a second one in December, and I'm real anxious to buy another one, but there's a reason I'm going to hold off, and you'll see that in the presentation. As far as notes are concerned, sometimes people are sitting back there writing feverishly. I always put my PowerPoint slides on my webpage. If you look at the bottom right-hand corner down here, if you go to trainelectronics.com, which is my electronics and training website, or if you go to davebodnar.com, there's a link to presentations, or send me an email. There are some business cards over there by the 3D printer. It's got my email address on it. I'll get you in touch with that presentation. Okay, hello. We're not going to work. There we go. Being a former teacher, I always have objectives. We're going to have an overview of 3D printers and printing. This is really neat. You don't have to be able to create your own stuff to use a 3D printer. There's a ton of stuff online, much of it for free. We're also going to look at a free program called SketchUp that will allow you to make your own stuff to print on a 3D printer. We're going to create some things in SketchUp. I'll show you how to do it. We're going to take those designs, transfer them to the printer, and even though I said, set up the printer and print the design, we're not going to do much of that because it takes forever. It doesn't take long to set it up, but you just walk away. There are many prints that I do that I set them up and I get up in the morning and they're still printing. Takes a while. Okay. Why are 3D printers becoming common? Anybody know? They've been around for about 30 years. Why do we see so many in the last 4 or 5 years? Word starts with P. No. Patent. Many patents have expired, opening up the hobbyist and home markets. Prices have dropped because of that. Software has become more usable. You really had to know AutoCAD 3D in order to use a 3D printer 10 years ago. And that is not a trivial thing to buy, nor is it a trivial thing to learn. Vendors are highly motivated right now to innovate and sell printers. Why? They want to gain market share before what? That printer over there is made by a company called Athena. Anybody ever hear of them? Yeah, well, one person. Congratulations. I mean, what if you had a choice between buying an Athena and buying an HP, and the price was about the same? Which way are you going to go? So, okay. Now, coincidentally, today is the 21st. This is dated the 19th. I don't know if you can read it. Sure you can. I'll give you a second to read that. The short version is in June, HP is going to make an announcement. I would expect in the next week or two some prices are going to drop. HP has said that they have come up with some new technologies to improve and simplify the 3D printing process for the home. You know what they're going to do? They're going to sell the printers fairly inexpensively, and the stuff that you print with will be proprietary. Okay. Printers. The best way that I can describe a 3D printer to you is an electronically moved hot melt glue gun. If you took a hot melt glue gun and pointed it straight down at a piece of metal or plastic or whatever, and you could drop precisely metered drops of hot melt glue and build up an object, that's what a 3D printer does. That's what that guy's doing right over there, but instead of using hot melt glue, it's using very hot melted plastic. The type of printing that I'm involved with and the type of printing that most hobbyists and home 3D printer users are using is called FDM, fused deposition. And what that means is you melt and fuse the stuff and deposit it onto some platform, also called FFF, or fused filament fabrication. Most 3D printers print in ABS. ABS is Legos. Pretty strong stuff, relatively inexpensive. Some of them use something called PLA, and I'll talk about the difference between the two of those in a couple of minutes. Now, there are other printers, and the one that I really want to get is right there, that print in resin. The resin printers use a laser to fix the droplet of resin. Well, how tightly can you focus a beam of light? Just to give you an idea of the resolution of the resin printers, jewelers are using them to make objects that they will then use to make molds to cast gold and silver. So if you're making a ring or a brooch or whatever, it's got to be pretty darn high resolution. Unfortunately, they start at about $3 grand and go up. So that's a little tough for the consumer market. Oh, other ones. Some of them print in metal. Again, I have no experience with that. Some of them print in chocolate, which is pretty cool. And there are biological ones. There are ones that will print cartilage. They've done ears, the support structure for ears and esophaguses and stuff like that. That's my printer. Not very big, weighs maybe 10 or 15 pounds. Simple units are well under $500. You can get into this for a couple $100. Mid-range, and that's what that is. I paid $15.99 plus a little bit of shipping and tax back in May, and they're still about the same price. That's my second printer. It's bigger. That's one of the things that you measure when you buy a 3D printer, is how big a thing will it print. That one will do about 5.5 by 5.5 by 5.5, which is not very much. This one will do 6 by 9 by, I think 9 or 10. So it's big. It also will print 2 colors at the same time, and I only paid $1,200 for it. Why? You see what the frame's made out of? That's laser cut plywood. It's open source, which means there's no patent, there's no copyright, there's nothing. It's all open source stuff, and it was made in China. Now that one was probably made in China too, but it came through a US distributor. And you can spend, how much you got. Most of them have 4 computer-controlled stepper motors. Now, if you don't know what a stepper motor is, you've got a bunch of them at home. They're in your printer, your inkjet printer, or you remember the old daisy wheels that had a stepper motor is just a very precisely movable motor that moves in very, very tiny steps. There are 4 motors. One of the motors has a geared wheel that takes the filament and pushes it through a nozzle. So it's the one that pulls the trigger on the hot melt glue gun. But again, very, very precisely. And there's one for each of the 3 axes. When you're printing a 3D thing, what do you have? X, Y, and Z. So you've got X, left to right, Y, front to back, and Z, up and down. And that's where some of the money comes in, because the stepper motors aren't cheap. They're very well made, precise devices, and the electronics to drive those things in unbelievably tiny steps is also pretty high. Most have 2 heaters. Now one of the heaters, and they all have this one, heats the filament to about 450 degrees Fahrenheit. They tell you in the manual, if something's stuck to it, don't grab it with your fingers and pull it off. Have I done that? Of course. The other one, for some of the printing, for the ABS, the Lego stuff, you have to have a heated platform too. That platform right now is at about 200 degrees Fahrenheit. And if anything happens bad with that print, it's because people have been opening this door all morning. You don't want cold air blowing out. As a matter of fact, in my basement, I have hot water heat, so I have no radiator in the basement. The only time the basement's warm is when the furnace is running and the pipes get hot. So I built an enclosure around my printer that, out of plexiglass that keeps the drafts and things, and it's pretty much better since I've done that. ABS needs a heated platform. PLA, the other one, does not. Now, when you're ready to buy a 3D printer, I would highly recommend you buy this. This is Make Magazine's annual 3D printer review. That's all it does. And this happens to be the new one. Last year, this one came out. And what's on the cover? My printer. Why did I buy that printer? It was top rated by this magazine. And if you look at the new one, what's on the cover in white? Same one, different US distributor with some different bells and whistles, but it's the same printer. So it looks like I made a reasonably good choice. What will be on the cover in 2014 or 15, whatever you want to call it? Probably HP. Okay. All right, the two types of plastic, and please, if you have questions as we're going, feel free to chime in. ABS, again, requires a heated platform. Makes it more expensive because you've got to pay for another heating element. So the ABS printers typically start close to $1,000. It gives off a slight odor. Did anybody notice an odor when they came in? This is pretty much an open room. I am using ABS there. Okay. My wife notices it at home if I'm running in the basement. I don't too often. Maybe my brain is gone. If you don't have a good heated platform, or if you get breezes coming in like that, the print will start to lift as you're printing and warp, and it ruins it. I can pass some examples of that around. I think I have them here someplace. Here's a couple of prints, and if you take a look at them from the side, you'll see that they've lifted. So I stopped them while they were printing. Yeah, our ABS is, I think it's pretty strong, somewhat flexible, as you know from Legos, if you played around with those. PLA is a biodegradable plastic. A lot of people like the idea if you stick it in a landfill, eventually it will go away. Very little, if any, odor. More brittle than ABS, but I find that the PLA, and I'll show you an example in a minute, it warps less after you take it off the platform. With the ABS, sometimes it'll move a little bit when you free it up from whatever you're printing on. Depends on like if you're printing a U. And I'll show you an example of that in a minute. It's very strong. Now, this is interesting. You can get a PLA-based printer for as little as $2.99. That's not bad for entry level if all you want to do is play with it and find out what's going on. There's a picture of one. That's from a website called 3Deers.com. Looks pretty neat. Pretty big? What's that thing in front of it? That's a quarter. So you're not getting much of a print. Here's another picture of it with a coffee mug. It's about this big. And it's made out of laser cut plywood. I mean, it's a very straightforward thing. They're getting to the point where you can almost use a 3D printer to make a 3D printer. And that'll be pretty cool. Okay. Now, once you buy a 3D printer, what are you going to do with it? Well, I didn't have anything to do with mine. Fortunately, let me show you the first thing of any significance that I printed. And I printed a bunch of these. They're all over the place. It's a nut and bolt. This is an example. When I was looking to buy a 3D printer, I sent an email to the company, the Makerware, that makes one of 3D printers. They sent me this. And it was the coolest thing in the world. I mean, I got something that was made with a 3D printer. So I'll pass these around. You can have that one. Pass it around. You can have this one. You can have this one. You can have that one. Okay. And I also, because it was fun, I made a big one. Okay. So I didn't design that. I downloaded that from the web. There is a web page called Thingiverse, you know, like Universe of Things, that has over 100,000 downloadable things that people have put up there for free. It's pretty cool. If you do, remember one thing from this presentation, go to Thingiverse on your computer tonight and just look at what's available. A lot of neat stuff. You can search for model train or trains within Thingiverse and get. There's a shipping container, a tank, some sort of a load, some sort of a tank, some kind of Thomas sort of thing, some gears for trains, track, all kinds of stuff. This is my favorite, and we'll talk more about this a little bit later on, but have you been watching this? Hopefully you saw it when you came in. I've got another one I can hold up here somewhere. Here. I'll pass this one around. This I got off the Thingiverse. And it's absolutely spectacular what it does. And what a great way to test your printer. Plus it's kind of neat. All right. This past summer, our home was on the local municipality's garden tour, fundraiser type thing. And I have a coffee mine on my railroad. Everybody in Pittsburgh has a coal mine, so I have a coffee mine. And I needed a wheelbarrow to carry. This guy was going to take some coffee beans to the coffee tipple, and I didn't have a wheelbarrow in the proper scale. I went to Thingiverse, and look what I found. And who cares how big it is, because you can scale stuff. So I printed a wheelbarrow, and I think I have it. I think there are 2 of them. And actually, these are just samples that I made. I think I made a bigger one for the guy who was actually moving the coffee beans. Is anyone keeping track of my steps? Because I'm trying to get a workout today. All right. Look at that. That's a whole passenger car that you can print. I think you're a lot better off to go back and get the laser cut one that the guy's doing back here, but yeah, it's kind of neat. All right. Chances are good that you'll find something that will fit what you need. If not, you can get something similar and perhaps you can modify it yourself. Chairs? Oh yeah, Bob will grab some chairs for you folks. Here's a good example. I was thinking of things to show you folks at this presentation, and I said, well, you know, doors and windows for buildings, I know when I'm building buildings, it's always a pain for me either to cast them or buy them or to make them out of wood. So I went to Thingiverse, searched for windows, and look what I found. And you'll notice that the windows are in 3 pieces. You're welcome to take these out and fool with them. And some of the pieces have come apart, but that's okay. But there are 3 pieces, and they're not bad. And could I make them bigger? Yeah. I can scale the stuff up or down. It doesn't really matter. So if you're doing HO, that's fine. If you're doing 129 or 120, you can do whatever you want.
And that's all on that Thingiverse.
That's Thingiverse. Now, if you don't have a 3D printer, but you still want to get some stuff done, there is a paid website. You don't have to pay to get on it, but you have to pay to get the stuff, called Shapeways. And what Shapeways does is, let's say that I designed a window, and I was very proud of it. I could put it on Shapeways, and I could say, okay, I want $5. And Shapeways will then add its cost of printing it in plastic or metal or resin and add $15 to it. So for $20 or whatever, you can get that window. It's a neat model, and a lot of people are making money on that. They will print in all kinds of things, metals and plastics and resins, yes?
What if I wanted to do a model of you?
There are scanners. And I don't really have scanners in the presentation because I'm not real impressed with them because they're not real precise.
What's the basic method? That
they use a laser.
And they
the same type
photographs of you from various
the ones that I've seen, actually, you would stand. You know, there are scanners right now that will scan you and tell you what size jeans you need. It's that kind of technology. So it's a laser that bounces off of you and it makes, moves around you.
This is not something that's going to be out for $1,000.
Well, yeah, your little one. There's a little one right now that's out for $1,000. I wouldn't fit on it.
Right.
You might get my, hand on there. But I've not been real impressed. I almost bought one when they came out. But to give you an idea of how successful they are, when they came out, they were $1,600. Within a month, they were $999. So, okay. Now that's not to say that technology isn't getting better and improving, but it's not real great right now. All right. Have you heard of SketchUp? It used to be called Google SketchUp. Have you used SketchUp? Okay, good. It was originally designed by Google so that if you wanted to rearrange your living room, you could put chairs and couches and tables and stuff and move them around in a 3D room and then walk through the room and say, honey, this is what we should do with, you know. And it grew. It's been around for about 10 years. So it's pretty cool. It's been expanded and enhanced to be a first-class 3D design program. Here's the nice part. It has an absolutely huge community of people that love to write about how to do certain things in Google SketchUp. I did a Google search, and again, I don't know how well you can read that. I searched for SketchUp tutorial video. I got 1,350,000 hits. Now that's not to say there might only be 100 good ones at the beginning, but that's how I learned SketchUp. I sat and watched videos. And I would have the screen split. I'd be watching the video over here and I'm playing with SketchUp over here, and I learned quickly. And I'll show you some of that stuff in a minute. Price is right, free. Be careful though. Bob wanted me to caution you about this because he made this mistake. Oh, I digress. I'll come back. There's also a free warehouse of things in SketchUp. I was going to do an outhouse. And I searched for an outhouse and I found that. Believe me, that's a heck of a lot better than David can do. I'm not an artist. I can download that, make some changes, and print it. There's a barrel. Tons of things. All right, this is Bob's comment. We were talking at dinner last night. He said, make sure that people get the free version, because when you go to their webpage, it's going to ask you, I plan to use SketchUp 4. In the drop-down, put in personal projects. Don't put professional stuff, or whatever the other words are, because it's $500. And there's the only difference between the two of them is in the professional one, it will give you like a build list and a contractor's, whatever you need for as an architect to give to a bidder or whatever, that fancy list of stuff that I don't need. Okay. It'll work on a Mac or a PC. Best to use, everybody know what a wheel mouse is? And I don't know, does a Mac have a wheel?
Some of the Macs.
I don't know, I'm not a Mac guy.
Would you be able to use a pad?
I don't recommend it, and I'll show you why in a minute. The reason is the wheel zooms. And that's a heck of a lot easier than choosing the zoom tool. You with me? Yeah. And if you hold the button, the wheel down, at least on a PC, you can do what's called orbit. And it's a lot easier to do that than it is. You can do it with a touchpad. And this morning when I was practicing at the hotel, I used a touchpad. But it's quicker with that. Okay. All right, let us sit down. Oh, you're already seated. Okay, we're going to start some stuff here. And if I can find, let's see. And you're going to have to excuse me because I have about 14 different versions of SketchUp on this computer. Ah, that's the right one. When it starts, and I guess they do this to help you to visualize what you're doing, there's always a guy there. I don't like the guy, so I always click on him, right-click, and type erase. Get rid of him. And I'm going to load something in. I'm just going to load in. Is that cool? You can do that in about 4 minutes. That smokestack. We'll show you how in a minute. But what I'd like to show you, when you're using this program, a couple of tips. You see up here where it says View Toolbars. You see all these little guys up at the top of the screen, all those little icons? Those are the various tools. You want to set your toolbar up like this, those ones that I have checked. And I have that on the presentation right there. That gives you all the tools you really need. If you check them all, you'll go crazy because there's too much stuff up there. So limit yourself to that. Then what you want to do is load in and practice orbiting, moving, and zooming. Let's do that. And I'm going to use my wheel mouse because that's fun. This little guy here, and if you put the cursor on it, you see where it says orbit? I just let it sit there and it's telling me what it is. If I click on orbit, look what I can do. Is it hollow? Yep. Look from the bottom. That's pretty cool, huh? That's orbit. Here's move. This one, if you screw up like that and you don't know how to get it back, this one I use all the time. It's called zoom extents. What does that mean? Zoom to the extent of everything that you've got on the screen. Click, and it's right in the middle. Make sense? If I lose the stupid thing, zoom extents will bring it back for me. Then this one I use all the time. You see what these are? They're views. This is a view from the roof. Well, what would that be? Straight down. They're straight down through the tube. What's this one? From a side view. Pretty cool. This is from an edge, which of course edge, 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 and edge on a symmetrical object are all going to be the same. But you get the idea, and if I hit zoom extents, I get that. It's not bad. Now, if you're using a wheel mouse, watch what happens when I just hold the button down, the wheel, see what it does? I can do it right there, and if I spin the wheel, that's pretty cool. Everybody with me? All right, questions? Well, I wish my 6th graders were like you guys. Okay, we got all my tools. All right, we're going to make a 3D sign, and let me pass some 3D signs around. And while I'm doing that, you want to look at this one, because we're going to talk about this in a minute. See if I can do this without pulling it apart. That's one of my 3D signs. I'll pass these around, and some people ask, how well does this stuff hold up outside? This sign was outside from June of 13 until about a week ago. And as near as I can tell, it's fine. And there's a piece of plexiglass glued to the back, so just ignore that. Pass those around. How did he do it in 2 colors? We'll get to that. All right. What you want to do to make that sign, and we're going to do it in about 2 minutes. Please don't time me because I'm not very reliable. We're going to do a new, okay, I'm going to get rid of the guy. Always like to start clean. And what it says for me to do is draw a rectangle from the origin. The origin's where all those axes meet. That's 6 inches by 2 inches. Now, how do you do that? This is the coolest thing. And when I discovered this on one of those YouTube videos, I was like, yeah. Let me go back. I'm going to draw a rectangle. Well, do you see a tool right there that looks like a rectangle? Give you a hint. You can also hit the letter R. And after you've worked with this for a while, you're going to learn all the keyboard shortcuts. Instead of clicking on orbit, you hit O. Okay, I'm going to hit the rectangle. Is that a rectangle? Yeah. How big is it? I don't have any idea. And what did it say back here? Make it 6 inches by 2 inches. Do you see in the bottom left-hand corner? Oops, no, you don't. It says 13 feet 3 and 5/16 by 23 feet 8 and 3/16. I don't want that. What did I want? 6, 2, right? I type 6 inch symbol, comma, 2 inch symbol, enter.
No space.
No space. I don't know if it matters, but no. What happened? Well, it's there. What can I hit to get it back? Zoom extents. Why is it so small? Because the other one was humongous. Remember, there was a 6-foot tall guy there. Okay, everybody follow what we just did? All right, pretty cool. Draw a rectangle, we did that. Zoom extents. We're going to pull him to 1/4 inch thick. This is cool. See this little guy here that has the rectangle with the arrow pointing up? That's a pull. Hit that. Watch. You see what it's doing? Now, look in the bottom left-hand corner. Can I just go till it says 1/4 inch and let go? Yeah. Could I have also typed 1/4 inch, enter? Yeah. And just for fun, let's look at it from the roof. See what I did? I just clicked on the roof of the house, so I'm looking straight down. Okay. Could you do that? Go ahead.
You do that in metric also, or just?
Yes, you may. You can, when you start SketchUp, it says, what basic template do you want? Do you want metric? Do you want English? Do you want blah, blah, blah? Do you want decimal inches? Do you want architectural? And sometimes I do use millimeters, particularly if I'm corresponding with somebody that lives in a funny country. We're right, the rest of them are. Okay. All right. View from top. We're going to draw another rectangle inside of the first rectangle. And we're just going to wing this one. I'm just going to do it freehand. Rectangle tool. I'm going to start here. Oh, I'm using the touchpad, by the way, which is a little harder. I should use the mouse. Does that look pretty symmetrical? Yeah. Close enough. All right, another rectangle. Now let's go back to my instructions. Use the push-pull tool to recess the second rectangle by 1/8 of an inch. Has everyone gotten to see those signs yet? They're going around? You'll see what we're doing here in a minute, right? Okay. We're going to get back, and I can't do it from this view. What do? Hit the kind of angled view and zoom extents. What do I want to do? Go down 1/8 of an inch. Hit the pull me guy, only now the pull me guy becomes a push me guy. Because I'm going to click here and go down, it says 1/8 of an inch. Actually, what does it say? -1/8 inch. Is that cool? I just did the recess. Everybody with me? All right. Is this doable? I know, with me sitting right next to you, yes. Okay. View from the top. All right, now, here's where it gets interesting. We're viewing from the top. Notice the perspective. Isn't that neat? We're going to choose the text tool. Now, the text tool, enter the text, and I want coffee, mine, dangerous. Okay? And I can choose whatever font I want in a regular, bold, and centered. But the important thing is right here. How high do I want the letters to be? And how much do I want to extrude them? Well, remember, I dropped down 1/8, so I want them to be 1/8. So I'm just going to say place. And it's not where it belongs, so let's put it all the way to one end. That's not good. What do I want to do? Stretch it. And stretching, let's go back to the notes because I went to the trouble of making them. There's your notes on how to set that up. Use scale to fill the frame. So we're going to choose the scale tool, which is right here. Scale. Now the problem, if you look, I guess I can do it here. If you look right here, you see this little green guy? That's actually 3 of them. One lets you scale the top, one lets you scale the bottom, and one lets you scale what we want. It's in the middle. So what do I need to do? I'll just orbit until I can find it. You see it right there in the middle? And as a matter of fact, I'm going to zoom in a little bit. That's the one I want. And I'm going to go down. Now let's go from the roof. Zoom extents. Does that look pretty good? Let's orbit around it and see if it's what we want. See the perspective? That's pretty cool. That's pretty cool. Did that take us 2 minutes? Well, yeah, maybe in a little bit more, but it's not that bad. And once you do one, could you make 50 of these things? I made a whole bunch of signs, not exactly like this, but close to it. When we did that a garden tour we were on this last summer, I did for her plants. She gave me a list of all these words that I couldn't pronounce, and I made all kinds of signs for her. Okay, question?
Reduce that to take how long to print it?
I don't know. Hour. I'm just guessing. It also depends how complicated it is, how many, but hour and a half. It's not trivial. For me to do our signs took a couple days. And I did a chess set for a friend of mine that designed a new chess set, and it took 32 hours. It was an hour for each piece. So, yeah.
Do you save that as a file to your own computer?
Absolutely.
How's it saved, you know?
If you're saving it in SketchUp, it's an SKP, which is SketchUp. But we're going to see in a few minutes, there's a generic file called an STL, stereolithography, that all 3D printers use. And we're going to save it in that. Okay. Someone else? Question? Yes, sir.
Did you get anything of a logo or something? Can you drop that in and use it?
Yes, sort of. You're not going to be able to manipulate it quite as easily, but you can trace it. But I've never done what you're asking, but best choice is to Google it and see if somebody has good steps. I'm going to show you something that uses a JPEG in a little bit, but it's not doing exactly what you described. So the answer is sort of.
How about another format, the PNG or DNG or?
Doesn't matter, they're all going to be bitmap. Yeah. Now, if you brought it in as like a CDR or something like that, a Corel Draw, which was a vector, it might be easier. But, you know, let's stay simple for now. Okay, there's our coffee mine, and after we stretch it, it looks like that. Okay, here's a neat trick. My printer will allow you to pause the printing in the middle of a print. Pull out the blue filament that I've got in there now, put in white filament, and continue. The two-color print that you were looking at, how did I do that? I printed the first 1/8 inch in color A, swapped filament, printed the second 1/8 inch, which was the outside border and the letters in the other color, and it worked fine. Yes?
So does it allow them to program it that way so that it doesn't over-color?
I believe the new version of the Athena software will allow you to put in a break and say, when you get to layer, and they don't do it in 1/8 of an inch, they do it in layers. And I forget what the conversion is, but let's say it's at layer 200. When you get to layer 200, beep a few times and stop. And stop's the wrong word, pause. But yes, what I had to do, because I had the older software when I did this, is I had to sit there and actually when it first started printing a letter, I let it finish that layer in the base color, and I said, let's pause, switch, and go back to it. Now my other printer, remember I told you I have two. That big one with the wood, that has 2 print heads and 2 spools of filament. And it will do it. As a matter of fact, let me pass something around for you. I do a 2-color cupcake. That's an example that came with the printer. Okay, let us continue. Pause. Okay, I already said that. Another neat trick. You see my little sign? That's one of my signs with the second half of this presentation. Third half is the case maybe. Kind of going around there. That's a blue and white sign. Okay. We're going to do some steps and a platform as you would have next to a station. I lost mine on one of my buildings, so I figured this would be a good thing to show you guys. We're going to do something like that. Okay, that's what we're going to build. We're going to make it real simple. We're not going to try to make it fancy this first time. But we're going to be able to do that, again, don't time me, but a couple of minutes. You know, if I was left to my own devices, I could do it in 5 minutes. First step. Do a new. Do I want to save this? No. Get rid of the guy. There's probably some way that you can say don't start with the guy, but, you know. All right. There's a guy, he's gone. Draw a rectangle from the origin. We're going to do this one in real scale. Like a platform might be 8 feet by 3 feet. So I'm going to type 8-foot symbol, comma, 3-foot symbol. So let's go do that. Rectangle from the origin. How big? I don't know. And it was, what was it, my number? 8 by 3. 8 feet, comma, 3 feet, enter. Easy. Next step, pull it to 3 feet. Get my little pull guy. You see some common things we've done before? Is that 3 feet? Of course not. 3 feet, enter. Okay? Now, one other comment. The first time I went to do this, for this group, I wanted to make this as part of the presentation, I pretended I was a carpenter. What a royal pain in the ass. I'm a sculptor. What's the difference? A sculptor starts with a big piece and takes stuff away. A carpenter starts with a bunch of pieces and puts them together. This program, it's a lot better if you're a sculptor than a carpenter. You'll see why in a minute. Because I had to make sure every one of those damn legs was the same and it wasn't skewed and, you know, you got a big block of granite. Let's continue. All right, we got that. There's that. Okay. Now, this is really cool. And I did not know this until I watched a couple of YouTube videos. There is a tape measure that lets you put marker lines on the drawing. And I want to mark this for 6-inch steps, which is about right, and 9-inch treads. Everybody with me? 6 up, 9, okay. Watch this. This is cool. Let's do a zoom extent so we can see it better. This is the tape measure. It looks like a tape measure. I'm going to click there, whoop, and go over. Do you see that line? Is that 9 inches? I have no idea. But I'll type 9 inch, enter, and now it's 9 inches. Do it again. I think I need 5 of these. Whoop, I didn't get it. Wait a minute. 9 inch, enter. And if you're careful, you can just draw it. See, kind of snap to 9. It's smart enough to know, oh, he did 9 last time, maybe he wants to do it again. And I think I'll do one more just in case. 9. And then what do I do down here? 6. 6 inch, enter. Hopefully everyone sees what I'm doing. Would you do this if you were a carpenter? You know, you might do a chalk line, or, you know, or if you're a sculptor, I guess. Whoop, screwed up. You know what I haven't had to show you yet? My favorite key on the whole thing. Anybody know what this is? Undo. Man, I'm good at undo. Okay, we've got the basic step laid out. Grab a pencil. You're going to like this, guaranteed. We're going to start here. Everybody with me? Oh, I screwed up a little bit. Let me do an undo and do that over again. I wanted to go to the intersection. You see where it pops up and says intersection, so you know you're on the right spot? Okay, let's do a quick orbit so we can see it a little better. I love this part. Click on my little push me, pull me tool. You ready? I mean, that's pretty cool. Now, could I have done separate rectangles? Yeah, that's what I did the first time. And I said, you know what? I wonder if I can... Yeah, that's cool. Okay, now, this is something else. Let me see if I put it in the notes. Get that. Get that. Oh, we want to make the platform 2 feet longer. Can you do that? Sure. Just do a, let's just do a quick view like this. Let's hit our push me, pull me. Pull that out, hit 2 feet. Now it's 2 feet long. Okay, let's go back to the notes. Erase the guidelines, because right now it's getting kind of busy and we don't need all those. So you go back and you click on Edit, Erase, or Delete Guidelines. Now it's clean. I want a 4-foot thick platform and I want 4x4 legs. So what do? Grab my tape measure, click here, type in 4 inches. I'm going to go down here, 4 inches. I'm going to go here, 4 inches. Whoop, that doesn't look like 4 inches to me. Let me undo that. Let me undo that one too. Hold on a minute. There we go. And 4 inches here. Whoop. Anyone have a question while I'm drawing here? Are you okay? And I'll do this one. I still need a few more guidelines, but that gives most of them. Everybody follow what I just did? Just guidelines. Now, this you're going to like. Guaranteed. Worth the price of admission. Zoom extents. Let's draw a rectangle here. And this is why you want to be a sculptor, not a carpenter. Click on that intersection. Go down to here. Now what am I going to do? Get the undo out of there. I'm going to grab my little push me, pull me. Until it flashes. It's gone. Make me a liar. Go ahead, see if I care. Sometimes it does this. There it goes. Cool. Let's do the same thing here. Get the rectangle, and we're going to do the same thing back here. Get the push me, pull me. And this one, for some reason, it sometimes leaves some residual stuff, which is no big deal. You just use the select tool, hit it, and hit the delete key, and it's gone. Now, do you see what I just got? Is that pretty cool? Now, the next thing I need to do, let me get the move tool here. I need to put another guideline in right here for the 4x4. Okay, that's for the other one. But I also need a diagonal line. Whoop, wait a minute, not that. I want to grab the pencil. I want a diagonal from about here to about, does that look okay? And then to here, and then up to here. Now what can I do with that? Get the push me, pull you? Again, it's a little touchy. I have the wrong angle is what I have. There. What's left? I've got to get under here and put in 2 more sets of guidelines. And even though this seems a little tedious, let me see here. That's 4 inches. And I want to come down, I'm going to make a rectangle. Now I can't go within 4 inches of the top. I'll go from about here to there, do a push me. There you go. And that prints. That will print just fine. Now could you put all the cross braces and stuff in? Absolutely. We're not going to do it right now. Questions? Yeah, I used the delete key to get rid of that. Oh, for the whole thing? Oh yeah, like right now, if I wanted to get rid of that face, see I just clicked on that, I'll hit the delete key, and now it's hollow. Now you can't print that. Everybody see what I just did? You can see the underside of the steps because there's no thickness to it. By definition, it's infinitely thin. But how can I get it back? That. Now could I move this up? Yeah, I mean I could do some stuff, but you have to be real careful that because if you leave a hole, it won't print. As a matter of fact, the Athena software will stop you. And you know what happened is it stopped. I'll explain what happened there. All those people coming in the door and all that cold hitting there caused the thing to plug up and stop. Yeah, no big deal. It doesn't matter. I have other examples to show you, but that's the kind of thing that you get used to seeing with a 3D printer. Okay, questions on the steps? Yes? There are textures that you can do. Yes, I'm not real good at it, but yes. You will get a texture depending upon how you print it. Because if the top surface happens to be the surface that's against the table, you'll get the texture of whatever you're printing on. We'll talk more about that in a minute. But yeah, like that outhouse that I showed you from the warehouse from SketchUp had textures built into it. I don't even know how they did them, but they're pretty nice. Okay, we did all that, we did that, we did that, we did that, we did that. Okay, when I first did this, you've probably had experiences where you're so excited you fall off your chair. I wanted to do a smokestack. I have a shay, and one of my tunnels started to collapse, and I needed to make a smokestack for the shay that was about 1/4 of an inch lower. And I said, you know, I can do this, but I don't know how. I found a guy that had a tutorial on YouTube how to make a funnel. Well, smokestack is a funnel. Look, wait till you see this. This is so cool. First step, get rid of the guy. Okay. Delete. Okay. I want to draw a circle at the origin that's 4 feet in radius. And again, the size is arbitrary right now because we'll scale it to whatever size we want it to be. Go to the origin, type 4 feet, there's the circle. Okay? We'll do that in a minute. Okay, draw a rectangle up from the origin. Now this didn't make sense to me until I started drawing and I discovered why this is important. You draw a rectangle, if I can get it. Wait a minute. You have to, there, that's the rectangle I want. The reason you want that rectangle is we need a flat plane, that's redundant, but we need a plane to draw on. If you don't put a rectangle there, you're drawing in space, and who knows where that line is. That makes sense? You can't just draw in space. You have to draw. Okay. What we're going to do, let me go back to my notes. Use the pencil tool to draw half of the smokestack profile. I'm just going to freehand this. Let's do a little zoom extents to get it in. I'm going to grab the pencil, and again, we're doing half the smokestack. Just okay. We're going to start here. This is where it would plug into the boiler. And we're going to go over here. We're going to go over here. We're going to go up to here. We're going to go over to here. We're going to go over to here. And I'm going to go to here. I want it to be hollow, right? So if you took the smokestack and cut a cross section, that's what I'm trying to get. And I really made this a little bit thinner than I should have. Let me see if I can cheat and use the mouse. Oh, that'll work. It's not going to be much of a hole in the middle. Okay. Now, I'm going to use the mouse. The only reason I haven't been using the mouse is it's right in front of the blower from the projector. It's frying my hand. Okay. Now, let's make sure I did this right. I'm clicking on everything that's not my profile and hitting the delete key. Everybody with me? I'm getting rid of the center of the circle.
Attention in all. Attention in all. If there's an Ernie Scheidegger, would he please come to the front of the ticket booth? Ernie Scheidegger, please come to the front of the ticket booth.
This is my great moment. He interrupted me. You click on the circle. You ready? Do we have a drum roll? This tool, right here, it says follow me. Click on that, click on this. I got it! That's what I did, sitting in my living room. And what if I zoom, like, can I orbit around there? Is it hollow? Well, there's a little tiny hole. I made a little bit too small a hole in there, but you get the idea. Was that hard? Let's do it again. That was fun. Okay.
So what did follow me
It followed the circle.
from the bottom? Okay.
Yeah, it's a path to follow. Okay, let's continue. Let me do one that's a little bit, okay, we did all that. I want to make a fancier one. Now, you had asked about bringing in a JPEG. I'm going to start over again, save it, no. And how are we doing on time? Oh, it's not, we're almost an hour, aren't we? Yes. Okay. I'm going to make it a little easier. I'm going to cheat. Okay, let me tell you. Let me show you what I did. Again, I'm cheating a little bit. I'm skipping steps, but I can tell you what I did here. I made a JPEG of a smokestack, and I laid it in there as that rectangle to draw on. And upon that, I traced the outline. So you can bring a JPEG in for that purpose. And if I click on the JPEG and get rid of it, you see what I got. Now, if I get rid of this inner circle, let's do the follow me again. There's the follow me icon. When I click on this, what it says, just follow me around that circle. And that's what you get. Do you see these little arcs down at the bottom? And where did they come from? Right there. I put little bumpies on my outline. I mean, that is so cool. And there's so many things. Tanks on the side of a boiler for whatever, you know, whatever your imagination can give you, you can do. It is not hard. Now, is it hard to get it just the way you want it? Oh, absolutely. Yeah. You better have a bit of artist in you, but it's pretty cool. Okay, let's continue. Trace the outline, which we did. Give it thickness. Okay, we did that. Now, let's say we wanted to, let me do this again. Let's say I wanted to print that. Right now, what I would do is go File. You see where it says Export STL, Stereolithography, which is the generic. No object selected. Export the whole thing. Yes. And we're going to call it, okay, JPEG. And now we're going to find that folder. Which of course is not easy to find. You know what, I'm going to export it again to a different place because it's easier. Okay, there it is right there as an STL. Can you see it? Now, if I double click on that, that is my printer program. That's the program from the Athena printer. And could I print that now? Yes. Now, is it big enough? Well, each one of those little squares is a centimeter, so it's about, an inch and a quarter, inch and a half in diameter. If I wanted it bigger, you do have some options. You see where it says scale right here? I can click on scale. I can click on, let's say, 2. I'll make it double scale, and I'll say place. It'll put it on the, now it's beyond the scope. You see how it's too high? It's gone above that. So I'll scale again. Let's say 0.8. Place. And could I print that? By the way, I would not want to print it this way, and I'll explain why in a minute. You want to turn it upside down and print it. Well, there's a very good reason for that. We'll get to it in a minute. Okay, questions? So in the program, you can do scaling. I can do rotating. As I said, I want to turn it upside down. I can do that. Could I take one of these arcs off? No. You can't actually edit the drawing. You can rotate it, you can scale it, you can move it, you can duplicate it. That's about it. And if any part of this was in bright red, it would be the program telling you that I can't print that because you did a bad thing in SketchUp. You have something that has 0 thickness, that sort of thing. And I've gone through a lot of trouble to get rid of some of those. Okay, let's get back to our notes. We talked about that. What the 3D printer program does over here is it actually slices that thing into 500 layers, whatever the number happens to be, and once it's done slicing, it'll start printing one layer at a time. We did that, we did that, we did that, we did that. Okay, what do you print on? When you get a printer from our folks at Athena, I'll pass this around. They give you 3 pieces of this. This is fiberglass with umpteen thousand little holes in it. And when the plastic comes down, it sticks in the holes. And it acts like little grippers so that it's not going to lift up. So if you want to pass that around, you're welcome to. There's a little clip on the side of it because that's how you hold it to the heated platform. Just with those little clips. So that's one thing you can print on. There's a picture of it. I guess I should get out of the way, shouldn't I? And those little clips are what holds that down to the heated platform. Now, painter's tape. These were printed. They don't recommend it because eventually it's going to fatigue and shatter. Those little fiberglass plates that I'm passing around, that's about $12 or some insane amount of money that they want for it. I got this at the local hardware store for about 30 cents. It's a piece of single plate glass, and you put painter's tape on it. If you buy the 3-inch wide roll of painter's tape, and I printed right on that. Now, don't drop it. It's going to break. Don't run your finger up the edge. It'll cut you. Children. I'll pass that from here, and you can pass this one back from here. The other thing I want you to note is when I printed this, there is no plastic support around this object, and I'll talk more about that in a minute. I was able to cheat and get that to print. That's how I did my windows. That's a set of windows. As we hear a piece of glass hitting the ground. There are some gears that I printed right on the tape. Now, notice, can you see there's extra stuff around the edges? That extra stuff is called a raft, R-A-F-T, and that helps it to hold the object to the platform. If you were trying to print one of those smokestacks, where's my hand, the one I want to show you? Here. This is the smokestack. If I tried to print it this way, it would make a fairly small support down here and probably would bend over and crack off as you're printing it. So you print it this way, and I'll pass this around. This is a raft. When I did the blue painter's tape for the windows, for me to take that raft off of something as fragile as those windows, chances are good I would break the mutton bars. So I put painter's tape on the glass, and then I read on one of the web pages that I read, if you take hairspray and spray the painter's tape with hairspray, it acts as glue, ladies and gentlemen. and it helps to hold it. And I was able then to make the windows right on the tape without anything I had to take off, because this is a pain in the butt. You'll also notice when I pass this around, all this extra plastic going up the side, that is supporting those, remember those little curvy things I made on the smokestack? If you don't have these supports, they'll sag. Because the plastic is hot when it gets up there. Yes?
Can you use perforated printed circuit board?
I have done that. It works well. Yes?
One other question. Can you take a picture of like a smoke box front and then load it in and copy it?
You'd have to trace it, which would be a pain.
Scan it?
But yes, you could.
I see.
If you had a 3D scanner, you could scan it, but the resolution would not really be acceptable. It's not going to be as good as an extruded plastic object.
I see.
These things are not that high res. If you have the resin printer, yes. But this one, the resolution that you get here, it's good, but it's not wonderful.
10 foot more.
Yeah.
20 foot.
Well, no, it maybe even 6 at times. Okay, let's continue.
Does the software put the raft in there for you?
Yes. Yeah, when you go to print, there's a checkbox that says raft, no raft. But you better know what you're doing if you say no raft. There's a lot of cases it won't work.
Like the Windows had the full raft.
The Windows was no raft, and believe me, I don't know how many I ruined experimenting to do that, but I realized if I printed a raft, every time I tried to take it off of the platform, whatever it was, I broke pieces off, because those are tiny. When that bag went around, some of those pieces are a 1/16 of an inch in diameter. Yeah. Okay, there's also something called Captain tape, which is a high temperature tape. It's like painter's tape, only it takes really high temperatures. Painter's tape works real well and it's cheap. And glass. Any part that is horizontal. What I mean by that, if you're printing something and it has something that sticks out, if it sticks out at an angle like this, it probably doesn't need to be supported. But if it sticks out like this, what's going to happen when you start to print the first layer? It's going to sag. So you don't print all of those supports automatically. That's part of the slicing program. But they're a real nightmare sometimes to take out. Plan during design for where support material is going to fall. Supports can be hard to remove, believe me. And there's an example. That's our steps. Can you see that? That doesn't go great. I can change the contrast. But you can see our steps. There's the steps, the back of that. There's the raft going around that. And that can be a pain to remove. Notice I did not print the back legs. There's a reason for that. The reason I didn't print the back legs, first of all, most of the time you have that up against the building anyway, and if I printed the back legs, it would have built up a ton of support material in between the two to hold them, because otherwise they'd have sagged. Because I did it the first time and it was a nightmare to get it out. Okay. Okay, if you're going to print something, if you're going to print that is the worst possible way that you can have it oriented on the printer to print. Why? Everything under here is going to be filled. Does that make sense? Why? Because otherwise it would be sagging. This is a better way to do it. If I do that, the only thing that will be filled is what? The steps. And you had asked about textures. If this is done on painter's tape, you would have the texture of painter's tape on the deck of the platform. Because that's what it would print on. Painter's tape does have a little bit of dimension to it. What's the best way to print it? That's why I took the back legs off. Now, where do you have supports? In here. That's it. That one spot, because everything else is self-supported. And let me pass some steps around. Different sizes. There's one for you, one for you, one for you. I know, poor people in the back. That's right. Should have got here earlier, huh? Yeah, okay. All right. They tell you to stay with the printer for the whole print. If I'm going to bed, I ain't going to stick with the printer. But stick with it for the first 5 minutes, because if it starts to lift, it's probably going to lift in the first 5 minutes. Most printers also give you an estimate of how long it's going to take, and they also tell you roughly how much stuff it's going to take, 13 grams, 50 grams, whatever. We didn't talk about price of filament, and I should pass some filament around. Here's a spool of filament. You typically buy a kilogram, which is 2.2 pounds, and it's about, depending upon where you buy it, 30 to 50 bucks a kilogram. Now, just to give you an idea, that little smokestack that you passed around, the white one, is probably about, well, you can feel it, 5, 6 grams, maybe. So what's it cost, 50 cents? Not a big deal. I have printed some other stuff. I'll pass some smokestacks around. Notice all the support material. Yes, I'm going to come to the back. There's 2 for you, and 2 for you. And I did not remove all of the support material just so you can see what it looks like. Some of these printers require you keep a PC hooked up and running all the time when you're printing. Some of them you can unplug it or turn it off once it starts printing. Some of them you can actually put it on an SD card and put it in. So that's a consideration. Now, use a putty knife to remove the raft from the table. Wear gloves. When you buy this printer, it comes with a putty knife and it comes with gloves. I only use the left one. How do I know that you need gloves? I have run this thing into this thing many times, and now I do not pick these up without wearing the gloves. And since I'm working on glass, yeah, but look how nice. I'll pass that back around. And you get a feel for it, but it's, you know, that's not a bad window. Well, this one once, because I just tore it. Well, you know what I do, though? If I notice I tore it here, the next time I print, I'll just move the stuff down, and you can pass that around, too. Okay. Questions up to there? Be careful, because you will hurt yourself. Yes? Question?
One of those is going around the trim stays up, and the other one stays down.
Sometimes I print, you can tell which way I printed it then.
Yeah.
That raft is always down. And I experimented.
But the trim didn't droop.
Well, on one of them it lifted. You notice the raft lifted and ruined the print. And I wanted you to see it. I guess I should have written on there or something. Yeah. I ruin a lot of stuff, believe me. This is not a household appliance. It's getting there. Maybe when he's there in June, we'll find out. And I suppose at some point I'm going to need a new glove, too. Okay. Yes? Yes, they call it natural. Yes. I've never tried. I mean, if you only printed it one layer thick, maybe, but it'd be so fragile you'd break it picking it off the platform. So, no. I'm going to say no. Here's some gears I was taking off. I'm fascinated by gears. I'll talk more about those in a minute. And then once you get the raft material and the gear off, you have to then break the raft material off of your good thing, which can be problematic. And that's another place you need the glove and the putty knife. And I also have a real sharp chisel. And I make sure I've got my glove on for that, because that'd take my hand off. But, you know, there's work involved. Okay. A couple of tips on printing. When you're printing with ABS, don't just turn your printer on and start printing. There's a choice in the setup, preheat the table. I typically preheat the table for 40 minutes or so until it's up to 100 degrees Celsius. And then I print. Because if you don't, it's probably going to lift. Don't use cheap filament unless you've used or heard from somebody that's really good and it's worth, you know. Cheap filament doesn't work as well as good filament. I don't know why, but it's true. If you buy the good stuff, it can be up to 50 bucks a kilogram. It does print better. Yes?
I'm noticing on the reel of it, it says it's 1.75 millimeter.
Yes.
Sounds different.
Yes, it does. Most current consumer printers are 1.75 millimeter diameter filament, but some of them are 3. And I was real careful when I bought my second printer that it was also 1.75. I was interested in one that was 3. I said, hey, I'm not going to have, not going to do that. Okay. Wear gloves, Make sure the table is level. If the table's not level, you're going to get stuff lifting too. Here's a nice trick. If you're getting stuff that's not sticking real well, take some acetone. Don't use fingernail polish because it has other stuff in it. Fingernail polish remover is not pure acetone. Go to the hardware store and buy a quart of acetone for a couple bucks. Clean it off. Helps it stick a lot. You can vary the density of the print to change its rigidity and strength and weight. Do you remember the cupcake I sent around? I stopped the cupcake print about a third of the way through. Notice it's hollow. I'll pass that around to you. You can tell it how solid to make it, and most of the time you don't need much in there. You want to keep your amount of filament use down because it's expensive. You want to keep the weight down, and it's just as strong. So you can see how open that is. The honeycomb affair. Okay, my favorites. We're going to do show and tell now. I make a model railroad speedometer. Where is my speedometer? It's one of the things that I market trainelectronics.com. And it uses a 4-line LCD display. And this is just a project box, fits in. You ever try to cut a nice square rectangular hole in a piece of plastic? It's a real pain in the butt. I can do it sort of if I use one of those vibrating multi-tool thingies, but I never get it right. I print out, look at this. That's what I'm trying to do, is get this display, and you see the gap down here, it's kind of ugly. Look what I did. Because I do indeed know a little bit about, I printed this. Little bezel. It fits right over, and nobody's any wiser that I screwed up underneath. It looks great. Now the other problem, this I was even more proud of. Does everyone know what an RJ11 is? A telephone modular plug goes into it, and the 6-pin was called an RJ11. It's a rectangle, it's about that big. Did you ever try to cut a hole in a plastic box that big, perfectly square, without some fancy chassis punch? I can't do it. I try it with a Dremel and a file. I'm trying to do that. I'm trying to do that. Now, I didn't make a bezel. Look what I did. This is better. I was so proud. Can you see what I did? I need some ahas. I printed a 1-inch circle with the hole in it. I can drill a 1-inch circle in that box, no sweat. Plug this in, put the RJ11 through, and I'm done. I'll pass that around. I was really proud of that one. Now, instead of spending 15 minutes with a Dremel and a file and all this other stuff, it takes me 30 seconds with a drill press, with a Forstner bit, cut a hole in it, pop that thing, and I'm done. It's not fancy, but it does a thing that I needed to have done. Okay. Here's another part. The way this speedometer works. This one happens to be for N scale. The one for G scale is really big. The way it works is real simple. I need 4 hands. If I break, there's 2 little infrared beams in there. And if I break them, it tells me what the scale speed is. Does that make sense? This thing I used to make by hand out of wood or plexiglass or whatever. Did you ever try to make 3 pieces of plastic, wood, or whatever, perfectly square, and then drill holes that were exactly 1 inch apart, 1/16 of an inch in diameter, and do it over and over again? No, not fun. Now, I'll pass these around. 3D printed. All I do is print them. I cut a tiny piece of 1/16 inch brass tubing that I shoved through the hole to make the hole precise. I'm done. By the way, one of these is ABS and one of them is PLA. The one that is ABS is splayed. You'll notice they're not the same. This one, when I took it off the platform, bowed out a little bit. So I like the PLA better than the ABS for this project.
So tough better?
Yeah, it seems to. Okay, question? Yes? I haven't tried the PLA outside. It's not water soluble. Because it's biodegradable doesn't mean it's water soluble. It is not water soluble, I can tell you that, because I thought, oh, that'd be really neat if it was water soluble, because I could print the raft in one, and
So then, have you used any of it else?
No. No.
UV resistance, that's important.
I don't know. You could look it up. I don't know. I know that the ABS is UV resistant as all get out, because that one piece has been out since June. It was out through a hot summer, right in the sun, and then all winter in the snow and cold. I kind of thought the two colors would have separated, because there was a little cool down in between the two. It has not happened. Okay. There's my little guy there. Oh yeah, well I told you about the spiral ball gizmo. You know what I did with that? I maintained the layout at Children's Hospital in Pittsburgh. I said, I've got to put something I 3D printed on the layout, so that's what I did. I had a little vignette. We have little people there, the Playmobil people, and the little girl's got a camera. And the little ball gizmo, if the kids push a button, the ball gizmo starts spitting, and she starts taking pictures, and the sign says, what is it? Where did it come from? Nobody knows, and that's what it's doing over here. Fun stuff. Beats the heck out of having a real job. I'm fascinated by gears, because I can never find the right size gears that I need to do something. If you back up from the current version of SketchUp and SketchUp 2014, if you go back to SketchUp 8, which you can get on the internet, there is a plugin, a plugin, like an add-on program, that will design gears for you. For whatever reason, they didn't maintain it. And look what you can do. They're called envelope gears, which are the ones that have little curvy things that touch like that.
Are you using ABS or PLA?
Yes. The question is, am I using ABS or PLA? Yes. I use both.
But the gears?
I don't remember. I don't think it matters. I don't think it matters. Isn't that cool? I designed the board, which has 1/4-inch holes to hold the gears at the right orientation. What did I make with that? This is what I made. Those of you that have been to my seminars before, I did a thing for Children's Hospital a year or so ago where I had eyeballs and an egg liner, and as the egg liner would go down the track, the eyeballs would turn and lights would flash. Well, it operated, but it tended to fail because there was a lot of mechanism in there for a servo and some escapements. I did it with gears, and if I can find my glasses, this is the set of gears that I printed, and hello? Hello? There you go. I'll pass that around. You just hold it by the bottom. Okay. Pretty cool. There's a close-up picture of the eyeballs and stuff.
Can they be printed with nylon?
It's a good question. I bought some nylon, and I had to buy a $30 platform for stuff and a temperature change, and I never got it to print well, and I quit. So the answer is, yeah, sure. You go ahead and tell me how. You know what? I'm sticking with PLA and ABS because I've gotten them to work real well. I found a vendor that I can get good ABS for about $32 shipped for a kilogram, which I think ain't cheap. It's ridiculous, but it's better than 50. This is one of the first things that I did. I'm a cyclist, and I fool around a lot with bicycle lights. Here we go. And I developed a circuit that will work with 7 LEDs. Wake up. And I put that on the back of my bike. I printed the box. And that's a relatively low setting, so don't look straight into the LEDs, but you can see the box that I printed. That's what motivated me to learn SketchUp, was to make that. Okay. You see the traffic. You've been watching the traffic light. That's from Thingiverse. And I just put the LEDs in it. I also scaled one down. Here, I'll pass this around. There's one with all the support material still there. Who's a good catch in the back? Pass that one out. I did not take the support material out because I wanted you to see what it looks like. You know those little things like this on a traffic light? They're all underneath covered with support so they don't sag. And it's a real pain to take all that stuff out. Okay, traffic light. There we go. Oh, everybody knows the little buildings that have a little bell tower that you always break the arms off the bell tower and get really irritated. I got irritated, so I built a bunch of them. I'll pass these around. Look how nice. I didn't print the bell. Here, I'll start with you. And you can have this one. And you can have this one. Whoop, I'm sorry. Here's that. And you know what's really neat? You see the pyramid little guy that's hollow inside? You know how I printed that? Instead of having it follow me a circle, follow me a square. Did I lose you? I had it, I did the exact same thing we do with the smokestack, but I started, instead of the circle, started with a square. And if I wanted a 5-sided, I'd start with a pentagon. And if I wanted an 8-sided, I'd start with an octagon. Cool. Okay. Absolutely. Absolutely. Yeah. Yeah. There's the drawing for the little tower. There's a tapered one I did. Question? Yes. I probably broke some of them out, or when people pass them out.
Well, it looks like this has a very thick portion.
And the other part?
This is thicker. So we don't know how.
You want to go over and talk to the program in my computer and ask it why it did that. I don't know. Okay. Questions? About an hour and 20 minutes. We have time for the second third half. Third. What did the car talk guys say? Third half. Okay. Question? Yes, sir.
How difficult is it to translate
STI, I have no idea. I've never tried it. Yeah, ask the Google. The Google knows all that stuff. Anybody else? Yes. It was $15.99, and I don't know the number, but it's the one they sold last year. They have a new one that's the same price that does auto leveling and stuff for the same cost. And if you go to athena.afina, maybe it's athenia.com, they have all that stuff on there. I recommend it highly. The people have, I'll give you a quick story about Athena. I've had 3 failures on this printer. I use it a lot. I put about somewhere between 8 and 10 kilograms through it. That's a lot. The stepper motor that drives the filament through the heater failed. They cross-shipped. No charge. The heater for the filament failed. Cross-shipped, no charge. And the heater for the platform failed. Cross-shipped, no charge. 1-year warranty, so I'm good till May. If I'd have paid for it, it was like $90 for the first thing, about $60 for the second, then about $60 for the second. It's not a big deal. You know, go ahead. Hopefully nothing, but I have replaced the nozzle. I keep a couple spare nozzles just in case, and sometimes the nozzle gets plugged, which is what happened here because it got chilled. Some people went out, and it's probably cold enough outside to chill that thing down to plug it.
My last question. Does it require a fairly consistent environment to operate that?
Well, again, in my home, I build a plastic box. If you've got if you've got forced air heat, and your temperature changes dramatically, you might want to just put a box around it. And all you really need, once it starts, to put a big cardboard box so there's no drafts. I built something out of plexiglass so I can see through it. It comes with the software you need to do this part of it, yes, and it comes with a pair of gloves and a putty knife, and yeah. They're nice. They're really nice people.
There's something there. See, there's a slit right there.
I don't think. It's not with this printer.
So I have you were using
the software that, remember when I changed the scale and flipped it over? It comes with that software. The SketchUp is free. You get that from SketchUp.
We originally, the software you were using to build things.
That's free. That's not from them, that's from Google. Well, it's actually that Google sold it, but it's still free. Yes. Okay.
Could you use a Dremel, like to remove some of the excess?
Absolutely. I've used Dremels, I've used files, I've used sanders, you know, whatever works. Yeah. Yes. 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 The slides will be on the website. Okay.